Slope-intercept form. Another very useful form of the equation of a line is the slope-intercept form. It's based on the use of the slope and the y-intercept of a line. Similar to point slope, we're going to start by showing a derivation proof of slope-intercept form. Let's start with the definition of slope, in which 2 points on a line are given by the ordered pairs x1, y1 and x2, y2. As a first step, let's just name the coordinates for the second point xy rather than x2, y2. That will be true for any point on the line, not just one point, and will allow us to write an equation for all points on the line. Then our slope formula becomes m equals y minus y1 over x minus x1. Now let's solve that equation for y. Y, right here, using what we've learned about solving equations. Try it yourself before we show you our answer. Hint, remember to treat the denominator x minus x1 like it's in parentheses. First, we multiply both sides of the equation by x minus x1 to get rid of the fraction. So now it's gone over here and it's on the left side, like here. Next, we're going to add y1 to both sides. And now let's just flip the whole equation around so that y is on the left side. This is fine and allows us to graph a line given any point. But one additional step is taken to get the most useful equation for a line. Use the y-intercept for the point x1, y1. The y-intercept is the point where the line crosses the y-axis, and the coordinates of that point are 0, b. So therefore, x1 goes away, and y1 becomes b. So, remember, x is 0 anywhere on the y-axis, and we just name the y-intercept b. Therefore, the line equation becomes y equals mx plus b. Slope-intercept form is where m is the slope, b is the y-intercept, and x comma y, so these two, x comma y, is any of the infinite points that satisfy the equation and are therefore on the line. This is the form of the equation of a line that is most often used. If you're provided a graph of a line, you can calculate m and read b directly from the graph. That allows you to write the equation of a line directly, which you can then use to find any other needed points. The line shown in the coordinate plane to the right has a y-intercept here at the point 0, negative 2. So b is negative 2. And it has a slope of 2 over 3. Because to get from this point to any other point on the line, we go up 2 over 3. Rise over run, 2/3. Therefore, the equation of this line is y equals mx plus b, where slope m is 2/3 and b is negative 2. Write the equation for the line shown in the graph to the right. What is the slope of this line? Alright, so we need 2 points on this line. Here's the y-intercept. It's at a point 0, negative 1. The y-intercept of the line is negative 1. And here's another point on the line. Let's calculate the slope. The rise over run. So we go 1, 2, 3, 4 up, and then 2 to the left, which is negative. So the slope of the line is negative 2. Therefore, the equation of the line is y equals negative 2x minus 1. All right, here's the solution. All right, this line has a slope of 0 because the rise over run, rise is 0. So 0 divided by any number is going to be 0. The y-intercept is at 0, this point right here is at 0, 2, so the y-intercept is 2. Therefore, the equation is y equals 0x plus 2, which simplifies to y equals 2. And here is the solution. Having the equation of a line in slope-intercept form also allows us to quickly graph a line using the y-intercept and the slope. For instance, if we know that the equation of the line is y equals negative 1/2 x plus 5, then first we can graph the y-intercept at 0, 5 here. Then use the slope of negative 1/2 to count the number of spaces down 1 unit and then to the right 2 units, or we could go up 1 and to the left 2 to get an additional point on the line. So remember, this is rise over run, but it's going to be a negative line. So we can go down 1 over 2, and there's our line. Then you just draw the line through any 2 points. This method is the easiest to use if you just have to draw a line given the y-intercept and the slope.